Okay, so I'm Jesse Weaver, member of the Titleist World Constellation here in the fourth year PhD student. I recently did an internship in the summer of 2011 at Facebook, and part of what I did is I exposed the Graph API as RDF and linked data. So in this discussion, what I want to talk about is the process we went through in turning it into RDF and how we supported linked data principles. I would also like to just talk to be a little more of a discussion, because I know we have some people here who have strong feelings about the standard that shall not be named and linked data. So, you know, I'm very open to criticism on how it could have been better. So, here's a little outline. I'm going to review briefly linked data, specifically the way these linked data URIs are supposed to work according to certain standards. And also, we're going to review briefly what exactly is the Facebook Graph API. So I just want to say right up front, the Graph API and the Open Graph Protocol are completely different things. This should not be confused. The Open Graph Protocol is ways of adding, RDFA into your pages so that Facebook can pick up on it and include it in their system, basically. The Graph API is an API for accessing things inside of Facebook already, right? So like users and movies and everything they've got in there, connections, likes, things like that. And it is aimed at developers, so I mean, this is not like something that your average Facebook user would be using. Also, I'll be talking about how we turn the Graph API JSON into linked RDF data, have some examples, and also talk about how we develop the schema in RDF. I don't want to spend a lot of time on linked data. I think most of the people in this lab should have a good grasp on this, but I think it warrants some review before we can discuss the topic. So in linked data, the idea is that the URIs you use to represent things or identify things, they should be able to be dereferenced in a meaningful manner. Now, there's a whole storm of emails and argument going on in the public law mailing list, okay? So if you don't like what I'm saying here, there's like a whole thing about reviewing the tag standard. Go talk to them. If I'm saying something wrong, feel free to correct me, but if you think that this is a bad idea, I'm not the one who chose it. The idea, though, the underlying idea is that when you dereference one of these identifiers, if it comes back with if it doesn't have a fragment and it comes back with 200 OK, then the thing that you got back is the thing that it identifies, right? So if you put in a fragmentless URI into your browser and it returns you a document with 200 OK, then the thing you got back, that's the document identified by that URI. That's things on the web, or so-called information resources, which apparently nobody likes this terminology. But then we also have things that aren't on the web, right? So if you try to dereference an identifier for me, I'm not going to magically squeeze through twisted copper pair wiring and show up in your browser. I exist outside of the web. However, you should be able to identify me, so there's some standards for how to do that. We'll talk about hash URIs and slash URIs. Here, the basic idea is, like I said, if the URI represents a document, when you dereference it, you should get a 200 OK. That's only for without fragments, right? And then if the URI represents a thing, and you dereference it, you should get some 303 redirection to a document about the thing that the URI represents. So just a few examples real quick. Here's a hash URI that identifies me. All right, so I have a faux file sitting out there on the CS server somewhere called folk.rdf. And I go ahead and append hash me on the end of it, and I call this the identifier for myself. Now, whenever you go and try and fetch something at this URI, you know, what your browser does and what the client is supposed to do is strip off this fragment and just look up what's here. So there's no fragment on here. It looks dereferences this URI and returns some RDF. And in that RDF, there's a description of it, including something that's identified by the local identifier me. Okay. So this is kind of, I think this is the easiest way to do linked data, but you know, there's advantages and disadvantages of the two approaches. We'll go over the other ones next. But the thing about this is you just return with 200 OK, and by slapping a fragment on the end, you're identifying something that's not on the web. Then there's linked data slash URIs. Again, the distinction between IRs and NIRs. I feel like I'm going to get in huge trouble for using this terminology after the big storm on the public law list, but you'll just have to forgive me. A URI for an information resource represents the document, right? So you put in the URI without a fragment, you get something back with 200 OK. That means that slash URI identifies whatever you got back. However, if you get a 303 and it redirects you to something else, we say that that URI represents a non-information resource, or rather, something that you're not going to squeeze through fiber optic cables. Your choice of interconnection. So here's an example of an information resource URI. This is just a picture of me. You look it up, you get 200 OKs, and back my picture. Okay, so this URI represents that picture that you got. Here's one, however, that represents me, but you get a 303, and it tells you to go from Jesse Weaver to Jesse Weaver /RDF, and there you're going to find a description of me. So that's how you know that it represents a non-information resource, or something that you're not going to squeeze over the web without using a fragment. So before I go on, like it sounds complicated, but if you're familiar with it, it's really not. If I can clarify this any better than I already have, feel free to ask any questions. So now that we've reviewed that, let's just talk about what is the Facebook Graph API. First, if you got a Facebook account, you've got your laptop out, go ahead and go to your timeline. Go to your main page. And in your browser, at the top with the URL in it, you're going to see http://www.facebook.com/something. And that /something is either going to be like the URL, or it's going to be something like slash and then profile.php $ID equals and then ID number. All right, so you're one of those two cases. All right, if you have the vanity URL, go ahead and cut that or copy that into your buffer. If you've got an ID number at the end, copy that into your buffer. Don't lose it. Now, go ahead and go to graph.facebook.com. Don't hit enter, just type graph.facebook.com/ and then paste your, whatever you copied there, hit enter. Anybody have any trouble or weird findings? No 404s, everybody got some little JSON back, right? Okay, so now you're looking at what can be retrieved about you. You can just keep that there for a while. That's your information in the Graph API. Now, one thing I want to mention is that that is not the sum total of what you can get through the Graph API. So people always tell me, oh, okay, so it's RDF, all I can find out is 6 or 7 things about myself. I can't even see who my friends are. You're right, you can't, because people didn't give you permission to see it. Right? People give you permission to view it, you have an app ID, and you put in your security token, you can get all that. Right? You have to go look how to be a developer and get all those things on Facebook. But if you're just going through without a security token, all you're going to see is stuff that's public. All right, Graph API. I'm going to read this to you, it's really small. Every object in the social graph has a unique ID. You can access the properties of an object by requesting graph.facebook.com/ID. For example, the official page is this number, etc. And you get back this kind of information. So you get back some JSON. This is how it was. It was only like this before we did the RDF stuff. And that was the only way you could get that information. Alternatively, people and pages with usernames can be accessed using their username as an ID, right? So I didn't care if you had your ID number, your vanity URL, or username, whatever you want to call it. You can put that at the end of graph.facebook.com/username or ID, and you can still get your stuff back. The ID is really the canonical way. Like it says here, everything in the Facebook graph, or everything in the social graph has an ID. Not everything is a username. So if you want to open up and kind of follow along, you can open a tab and type graph.facebook.com and just hit enter. It'll redirect you right to this page. The good thing about this page is all these links, like these ones right down here that say /me/something, access token equals ellipsis, right? If you click one of those, it's going to automatically generate a security ID that represents a security token that represents you as your user so that you can see your own stuff, right? Like it's not going to let you see everybody else's stuff. It's just going to let you see all of your stuff through the Graph API. So if you want to go ahead and click one of those, you can check out the stuff that people complain isn't there, but it actually is. They didn't 100%. all of the objects in the Facebook social graph are connected to each other via relationships. We call those relationships connections in our API. So the thing about the graph API is there's a distinction between connections and fields. Okay, so probably the closest analogy in the semantic web world is going to be like object properties and data type properties. Now, it's not exact because some of your fields are going to have like a URI as an object, so not exactly a data type property, but it's the same idea. You know, annotations about the thing versus relationships with the thing. I've already showed you all this. This is what you get back from the graph API. This is my information. As you can see, everybody has an ID. And I can just as well put that ID at the end as well as the username I used before. All right. I feel like as I go, I should be quoting Fox and Socks. Here is lots of new blue now. If you want to put a parameter on the end of that URI, put question mark metadata equals 1. You can find out a whole bunch more about yourself. All right. But what this does is it basically tells you what your connections are, right? We just talked about connections. So here's a link to your home, here's a link to your feed, a link to your friends. And then we also have farther down, all I did was scroll down here, we have the so-called fields, right? So fields are obviously different. The name, which is ID is a field, name is a field, first name is a field, middle name is a field. This is what you get from the Graph API. I didn't do any of this. This is how the Graph API has worked and still works, to my knowledge. And finally, at the bottom, when you put your metadata in, you get this little key. It's a special little key called type. We're going to tell you what this thing is. Right? In my case, I am a user. I hope I'm over there. Now here's an example of my likes connection. All right, so I said you guys could go to that page and click any of those links and get your automatically generated security token or access token. Here's a few things I like. I like Breyer's ice cream. Go get a bit of all right. I used to like Clifton Park Auto Body until they couldn't fix my car. That since I'm So, little cheap Mongolian hot pot and barely food in there. But these are some of the things you can get through the connections, right? So if you follow those connections I showed you earlier, so what I did is I picked likes, right here, likes, which is the same thing as what you're looking at, just put /likes on the end. And you get to see this kind of stuff. Now, the key feature of the JSON sent back to you for a connection is that it has a single key called data. And the value of data is just an array. So this is kind of a key structural feature if you're trying to turn JSON to RDF, which we'll soon be talking about. This is how you recognize, say, a connection from anything else. So what do we know? The Graph API returned only JSON. We've got objects, fields, connections, and types. And we can find out about almost anything if we know the ID by going to there, and also if you have the appropriate access token. Well, I'm not going to keep talking about access tokens. Keep it in your mind. So what do we need if we want to make this linked data? All right, so obviously we need to get URIs in here somewhere. We need to identify these things with URIs. Not just for the instances, right, objects, but we also need to get URIs to the fields, the connections, and whatnot. We need to translate the JSON to RDF, and then we use a few other special mechanisms, which I think might be the point of most heated discussion here, maybe if I'm lucky. And I'll just get to that a little later. So let's talk about how we turn the Graph API JSON into linked RDF data. So right now I'm only going to talk about how we choose the URIs. I'm not going to talk about the RDF. RDF is just like a syntax for your linked data. Put lightly, put loosely. Everything in Facebook has an ID, like I said. You can find out more just by pinning it to graph.facebook.com/. I had this interesting discussion with the developer at Facebook about what we should put here. Right? So we didn't want to 303. Say we decided not to 303, and the reason was it was felt this is the place for the information about 134.42 and 292. We don't want to provide it in another place. Didn't want to have a service redirecting here, all of which would have been fine with 303. But since we're already putting all the information about this guy in one page, we may as well go with hash URIs, right? It's the easiest way to go for the instance data. And that way you can just translate the JSON to RDF and be done. Don't worry about redirections. So what we ended up doing, now we have to decide, right, what fragment to use. Anybody see the email I sent to the linked data list just recently? Good. And you also didn't see what Tim Berners-Lee responded to. So let's just talk about this little issue here. When I first did this, this was hash me or hash this. Right? I had a keyword there. I thought, yes, Tim, it should have a keyword there. It should have a fragment. It should not be repeated. But people who are less familiar with forming the URIs for linked data thought, especially when we see the turtle later, thought it's just confusing. Why when I go to the JSON one, I see, oh, my ID is 134.421.292. Then I ask for the turtle one or the RDF one, and I see 134.421.292 hash it, hash me. Why? It needs an identifier. All I can tell you, it needs an identifier because it's something you can't get on the web. It needs a fragment. So as kind of an agreement to make the minimal change possible, we just put a hash. No, just an empty fragment. So this is probably not the best idea because, right, if you go and look at your public log mailing list today, Tim points out correctly, right? Tim is always correct. That this could be problematic for tools in the future. Like the whole idea of these URI identifiers is that you have a way of making a local identifier global. And what tools allow identifiers that are empty? Right? Like you can't go into C and name a variable nothing. I can't just put int colon, right? You can't do that in Java, you can't do that in Python. People generally don't do that. You identify your things with a local identifier. And here I've almost chosen one for like he who shall not be named. Like I didn't give him a name. So it's got its issues, but this is the way we went. It's kind of a compromise. So objects or instances are represented with these kinds of hash URIs, just by throwing a hash on the end. URIs for schema, all right? So we have to come up with URIs for these connections, fields, classes, ontology, if you will. So what we did was we just put a special access point under graph.facebook.com. They have some of these for other things, but we just named it schema. I once had describe here, so I thought it read nice. Right? Describe user, describe/user. Oh, that sounds nice. They didn't like describe, they liked schema. And they certainly didn't like ontology. I didn't even propose it, but it came up in discussion and they did not like it. So here's a URI for a class. What we did is we reserved a very special URI, which basically represents, this is like a class, right? So if you want to find out stuff about user, you just go to graph.facebook.com/schema/user. But in that page, you're going to find not only information about that class, but also the properties that apply to that class, its fields and whatever, right? Because we saw earlier, when you put metadata equals 1, kind of all of that comes on the same page. So what we did is we decided, well, for the class that's identified in this page, and there's only going to be one class per page, we'll just call it hash type. So your user type, this is the user class.
I'm ready for it.
So here, you can actually go here if you want to, go ahead and type in your browser, graph.facebook.com/schema/user. And you can see this at the bottom, it's telling you, what is this page describing? This isn't JSON, we haven't talked about RDF yet. It said, well, we're describing user. So that's URIs for classes. Now let's talk about URIs for properties, connections and fields. It's kind of a funny thing with the JSON, the output. We'll talk about it a little later. But it warranted the need for a distinction between generic and specific properties, right? So whenever you look at JSON, it's just key values, right? That key is just like name, all right? Name. I mean, is this name the same as his name The generic semantics one has exactly the semantics of that JSON key, right? It's like almost meaningless. It's the exact same level of semantics. And in order to represent the absence of its association with any class, we just put a tilde in here, right? So normally you have like schema user, right? So we got like schema tilde ID. This is just like the ID key. It has almost no semantics. Then we have the class-specific semantics because oddly enough, the fields are unique from their description based on being described. So your user ID is kind of different semantics from your page ID. It's kind of different semantics from the place ID. These kinds of things. Although, of course, they all have unique IDs. It's just that the descriptions for the properties are specific to the class. So for class-specific semantics, we still have schema/user, but instead we use a fragment of ID.
What's the relationship between the generic semantics and the class-specific semantics? So is user hash ID a subclass of
Subproperty.
or subproperty? Okay.
Absolutely.
Yeah. Okay. Okay.
And I know it sounds silly. Like, why do you even have this? This is so dumb. This is what we're trying to get away from. Yes, it is. But when we translate from the JSON to the RDF, sometimes they have these keys there where they just kind of like dynamically in their code. Oh, I'm gonna slap in some extra data under this key. And this key is not associated with this class anyway, but it's there. And I can't look up. I look up, hey, does user have a field called key? No. Well, now I can't give you a class-specific URI. So if I gotta give you something, it's gonna be some kind of URI. So I just give you the URI with equivalent semantics. So this is really small. You can go ahead and type in your browser though if you want, or you can curl it. I don't know if you're familiar with curl, but you're gonna have to put a -h except text turtle if you want to get the turtle out. Otherwise, it's going to default to JSON. What I want to notice here is what I've looked up is schema/tilde/ID, and I 303, right? So we do use some 303 URIs in here when appropriate. And the main reason is the content for these generic property URIs is dynamically generated. So what it's going to do is it's going to send you this /schema?tag equals ID, right? And then that's going to give you this. Right? Here are your JSON semantics. And this is still a JSON. So I'm describing tilde/ID, and the description is a tag having no semantics beyond the conventional semantics of the JSON key ID as used in the Facebook graph.
Yeah. So I guess what was your main design in kind of mixing both hash and 303 like that? Was there any need to be more consistent, or is it just more of a use case thing? I mean, I guess I can see the use case in this being more dynamic, but it's not understanding what it is.
I can give you exactly the reason.
Okay.
So whenever you look up something about user, right? Inside, I put my little code to say, go look up user, see what kind of things you know about user, right? And I know, okay, these 20 things or something, these are properties of users, everything else is not, right? The problem is when people generate that JSON, they start sticking in that, that dynamic stuff that's not really part of the code base for this class thing. It could be anything, right? Like we could put, fox and tag equals fox and socks. You could put anything they want in there. So
who's putting
So,
things there? Or why is it not more defined or more static in terms of what we define inside this vocabulary and space for understanding? I guess I'm not understanding the dynamic part of this.
So the things that are exposed to the graph API, so there's like a lot of things
Okay.
exposed to the graph, like over 20, I think. And user is obviously the most commonly known one, because that's what everybody sees. But whenever people design this data object, let's say, underneath and whatever storage and everything, well, they implement something that says when people ask for this in the graph API, turn it into JSON somehow. So they turn it into JSON somehow. Now, for certain classes of these things, I can look up information about them. Other things, if they generate the JSON and they decide to stick something extra in that's not based on the actual, let's pretend it's a table or something. There's no then when they add that thing in, I have to somehow generate a URI for it, but I don't have any semantics to give you for it. So that's why I have the generic ones. Now you're asking why 303. The reason 303 is when people implement these things, they can put whatever keys they want in there. So I can't give you every possible string known to man in one page and generate a hash URI, right? When you have a hash URI, you're going to one page and it's going to give you everything.
Yep.
And there's an infinite number of possible sequences. So I have to have some dynamic way.
Okay.
And so the best way, since I can't get the fragment, right? Whenever they put that URI in there, I don't get the fragment on my end. I have to somehow know, well, what meaningless key were they talking about? And that way I can dynamically generate this brief description.
And is this coming from, I'm assuming this isn't third-party people doing this, this is the actual Facebook developers who are adding
Yeah,
these things to the graph?
Facebook is pretty big.
Yeah.
And I mean, this is not like one team.
Oh, of course, yeah, I was just wondering where that was coming from, if that was on the Facebook side, or this was more of an extension, they allow some third-party addition to their graph or something like that, and that's where the issues were arising.
Because the requirements for publishing your stuff in the Graph API are pretty minimal. Like, you have to have an ID, okay, you have to have, I think that's it. I think you only have to have an ID. Like, my apologies if I'm incorrect about that, but the requirements are very small.
Mm.
So if they want to put in whatever they want in there, they can. Even if I can't look it up. But if I want to expose it as URIs, I have to have some URI for it, which leads me to this. But then if I want to dynamically generate what the meaning is, because I can't generate them all in one page because there's an infinite number of alphabetic sequences and whatever, well, now I can't give you hash URIs because I can't cram an infinite amount of data on one page.
Yeah.
So that's what led us to the 303s
Okay.
for this piece.
Okay.
I hope people on the public log list see this. All right, but here's the class-specific ID property. Okay, so you go ahead and put /schema/user. You want to put hash ID on there, but it just gets stripped off, right? So on my side in my code, I never see that fragment. The only reason I know to give you ID is because this is everything about the user. I just dump it on the one page, and since it's a finite amount of information, I can do that. And then I can look up these descriptions, right? Oh, the description of ID, the user's Facebook ID, no access token required, it's a string. And we even have the URI in here. So this, in some sense, this JSON version of the schema is kind of linked to that. And there are some things like identifier true that just basically means it's a inverse functional property, right? So people with the same user ID are the same people. All right, tag URIs. Here's a weird thing. Lots of gooey goo for chewy chewing. Nobody knows Fox and Socks. Just read it to my daughter like twice a day. So. Linked data rules really apply to HTTP URIs, right? It's like, how do you, well, aside from the one that says use HTTP URIs, right? Well, if you're not using HTTP URIs, then kind of that 303 and 200 OK stuff doesn't really apply. But sometimes you need to identify something with global scope, right? So no blank nodes. You want to have like global scope on the web, but you don't have anything to which a HTTP URI can be referenced. Now, this is a little bit of a miswording. Greg and I had a little chat about this, and I misspoke when I talked to him. I said, let's just go ahead and talk about it right now. There are some IDs, say IDs for comments on Facebook, which are really just the appending of two IDs. Here's the post ID and the user ID, and they put it together with an underscore in between or something. All right. So then if you go to graph.facebook.com/ID with an underscore in it, doesn't 404, doesn't give you a description, it just turns 200 OK in a single word, false. So that would really be the right place to get a description for that kind of thing. If it 404'd, I could go ahead and make an HTTP URI and say, well, they'll get to it one day and they'll do it right. But since they've already gotten to it and they didn't do it right, according to linked data, I can't use that. So I went with tag URIs. Open for debate. I welcome any comments.
So this is a case where they're just not following the HTTP standard in terms of retrieving information source that doesn't exist there, and now you're having to deal with that.
I wouldn't put it that way. Because what they've really done with the Graph API is they're trying to support developers by saying, you give us something, we'll give you something back, following some kind of standard that they made up. And maybe part of that is you ask us for an ID that doesn't exist. I mean, you can put, slash anything, gobbledygook or whatever after, and it will come back if nothing exists with that ID or username, it's just going to say false, right? So that may be like their contract with their developers. We will give you false if it doesn't exist, right? So I can't say it's wrong.
Well, it's not wrong, but it's the HTTP is wrong. That's not the right. That breaks
Why?
the HTTP standard of the client-server relationship.
Does it? I mean,
It's pretty explicit. If this client asks for something from the server and the server has no idea what the client is asking for, then that's a 404 error or something in the 400s, depending on what the context was. I mean, it's really explicit in the spec of these are the
yeah,
the
but what I'm
relationships
claiming
between-
is what defines what they should expect, the agreement between Facebook and the developers, right? So I mean, it's kind of relative. Yeah, they put it in, and if they don't have it, I should get a 404. But what is the it that they don't have, right? Well, that's kind of defined based on who's providing the thing. I'm not saying it's great. I just don't think it's incorrect according to HTTP. But it definitely will not work for the link data. Because false is not a description of the thing that you want to find in. So like I said here, ideally you should always use HTTP to dereference correctly. But in some cases, it just may not work out. So here's what a tag URI is. It's the scheme tag, colon, the domain name or your email address, comma, optionally, comma, and a date. So your date can be a year month, or year month day. And it's basically saying, at this date, I own this domain or email address. And so by convention, right, I don't have to go register with someone else. I don't have to ask someone, hey, can I use this URI? Because if I did do that, Facebook probably like, this is not worth the problem, not worth the trouble. But this is kind of by convention, Facebook owns this. Specifically this one, right? Tag colon graph.facebook.com, comma 2011. So what this means is on January 1st, 2011, graph.facebook.com was owned by whoever owned graph.facebook.com. So like this namespace, let's say, is owned by whoever owned graph.facebook.com in 2011. By convention, not that you couldn't go out and mint it yourself. Don't do it, but you could. So one of the specific uses, as I already said, is if I run into something with an ID with an underscore with it, for which I can't give you a good HTTP URI, I'll just go ahead and slap that ID right over here on the right-hand side of this tag URI. And that way I don't have to give you a blank node. You're welcome. You're welcome. So now I've gone through the nitty-gritty of how I generate URIs, right? So we had instance URIs by throwing a hash on the end of it, empty hash. And we have the class URIs, which is /schema /class name hash type. We have the class-specific URIs, so in user that's /schema /user hash property name. We have the generic properties, which is /schema /tilde / the property name. And then we have these weird tag URIs for whenever we can't get something that we should be able to get, but it doesn't 404.
So that's only the cases where you can't you just can't dereference it in the way we would typically talk about in the data.
Nope.
Is there?
But when you fetch the document twice, you won't have two different blank nodes. You'll have the one URI.
So it's just a global type identifier.
Exactly.
For this concept that we can't do anything in terms of HTTP.
Well, I mean, in theory, I could have gone out and, so I made /schema. I could have gone out and made slash IDs with underscores, and made up my own accessor there. But, maybe I didn't preface this correctly, but the goal here was provide sensible RDF link data requiring the least amount of changes to other people code and the least amount of maintenance in the future. Because there's no one there who's going to be able to fix this. If I don't make it robust enough and it starts breaking, this will disappear tomorrow.
But do you really think that's
Just tell them to
backwards compatible, and what if they do in some future state, support, this underscore, ID, HTTP, or, other things. And then how?
Well, I went ahead and left them a static class variable. So when they go in, they can just delete that value, tag graph.facebook.com, 2011, and put in http://graph.facebook.com/ put that instead, and that way the ID will pop up there, will go there, and it will not give you false if they did it right. And
okay.
so I left a few hooks.
Okay.
Code is not pretty, but I left a few hooks. So hopefully.
How is this? Well, I guess you're going to get into this in a moment, possibly. But did you do anything different in terms of the actual RDF to describe or talk about this tag right a little bit better? Or do you have anything that would tell if I'm some Blue data browser or something like that? Other than I notice it's not an HTTP URI, there's something that tells me, hey, don't even think about dereferencing, or hey, this is some metadata or some other things around this to describe what's happening, or.
So you can get some descriptions. You just won't get it anywhere that you dereference the URI, right?
Yeah.
So we'll look at the examples.
Okay.
With this coming up.
You don't need that. The scheme for that URI tells you can't dereference it.
Yeah, of course. Yeah, of course. Yeah.
But there is like RDF, that has, there are RDF triples that have that tag URI as the subject. It's just that you either trip upon it, otherwise you can't find it.
Okay.
There's no follow your nose for tag.
Okay.
So let's talk about now that we've talked about how we generate the linked data URIs, which is really, I think, the hardest part, doing it in a way that was clean and acceptable to us there. I don't think the public law was for now let's talk about how we actually turn the JSON into RDF, which is basically a syntactic conversion, putting the URIs in the right place. So I'm just going to say, let's define this function called RDF, and its domain is a JSON object. JSON object is basically your key value array. And for every key value pair, KIVI, I'm going to generate a triple, right? So the subject is going to take the whole object and somehow map it to the correct subject. Right? And then for whatever key value I pick, so I got KIVI, I'll use KI to generate the correct predicate, and VI and generate the correct object.
Did this take into account the URI for the actual JSON object as well? So for I'm assuming for the JSON class user that has all the objects coming out from that. If I were just to look at only the RDF or only at the JSON, is there anything in there that tells me the JSON itself that I'm talking about users? You'll have to know the URI I'm looking at that is talking about users.
Here we go.
Oh yeah. Describe. Okay. Yeah.
That's kind of the thing that you should remember here is doing this was predicated on the requirement that I don't make everybody change their code. People only generate JSON. So what you're seeing here is that nobody ever does RDF under the hood. You just do JSON. And I inserted some little layer on top that said, oh look, in HTTP someone said, I want text turtle. Well, I'm going to intervene and try and do my best to give them the best semantics turtle version possible. So it's just like this little layer there.
Is that happening dynamically then? Or is there something on the server end that they're like, oh, okay, well then here's the JSON, transform it immediately to turtle and then give that to the user? Or is that happening post somewhere?
So no matter what you ask for, it generates the JSON.
Yeah.
And then it says, oh, you want a text turtle? Turn that JSON into text turtle.
Yeah.
So it's just like this little thing on top. But it's got to be more than just a syntactic change, right? You've got to put semantics in there. So a little layer that changes it also lets do some lookups to say, where can I use the class-specific properties? Where can I only use the generic properties? Those kinds of things. So I'm trying to give you the most semantic version I can, but I can't always do that. I mean, when I say I can't always do that, I can't always give you a lot of semantics. You will always get turtle. Yeah. Ask for anything, you will get turtle. If you don't, send me an email. So let's talk about how do we determine how things get turned into RDF. If you have an RDF object that has an ID key, right? So this is like that one requirement I know about. Every object has to have an ID. Then I'm just going to go ahead and generate either this tag URI, which is if the ID has an underscore in it. But if not, I'll just append it to graph.facebook.com. Right, so these are your instance-native URIs. I also showed you that example of a connection, my likes. It has one key value pair. The key's name is data. The value is just an array. So I say, look, this object has one key value pair. Its name is data. This is a connection. And I'm just going to generate the relative URI hash. Probably not the greatest idea here, but enough, I guess. If I can't find any of those things, you're going to get a blank number. Right? So I can't think of anything where this should happen, but this is like my failsafe in the code. If I just could not figure it out, you're going to get a blank number. Also, regular arrays, right? So these are not key values; these are numerically indexed arrays. That you will also get a blank number. And those things change a lot, so I don't really want to mint a URI for that. It can change based on like you add more comments and they pop the top 10 things in there. And someone's in a comment, now your top 10 changes. So, minting the same URI, but its content changing over time doesn't really make a lot of sense. So I went ahead and put a blank number. All right, let's talk about the keys, right? How do I make smart properties? Basically, if I recognize the type, like I say, oh, this is described user, I know about user. There's some types that I can't really look up. It's so specialized. I have no idea what the back end is like, so I was just like, I give up. But a lot of them are in a usable form. If I can find that the type is known and that there's a key that's specific to it, then I go ahead and give you that class-specific schema URI. Otherwise, you're just going to get the dumb one that has the equivalent semantics to the JSON key. Of course, the exception is if you find the key type, I'm just going to turn it directly into RDF type. Right? So I said this is like the special class. The special key that tells you what type it is. Now let's talk about objects. All right? We talked about subject, predicates. These are objects. The objects kind of, you don't really know what to expect sometimes in the objects. So these are almost just heuristics. There's no looking up. There's no, so I can't say this is sound, right? But it's, most of the time it's right. If the string looks like a URI, let's make it a URI. Okay? It just looks like a string, make it a string. If it looks like an integer, make it an integer. Looks like a decimal, make it a decimal. Double. Date times are a little funny. Some of them don't have time zones on it, no problem, straight to date time. The ones that do have time zones, they don't have that colon in there, which is the way like everybody does it with XML schema. And so I gotta go ahead and put that colon in. You couldn't just say that it's optional. No, I gotta parse it out and stick that colon in there. And the same with the Boolean values. Okay? So your objects are kind of like really good guesses. Here are some special cases. This is probably kind of boring, but I'll just force my way through it. ID values look like integers. And before I said, well, if it looks like an integer, make it an integer. No, because some ID values have underscores in them. They don't look like integers. So IDs don't look like integers because they have underscores in them. So all IDs will be forced to be strings, whether it looks like an integer or not. Right? Type, again, is special. If you see the type key, then we know that the value should be a URI, and it should be turn it to a special schema. So these are just special cases. If it's a numeric array, I turn it to the special numeric. This is my solution to RDF container membership properties, which is only marginally better. We'll get to it. But it's not as dumb as the other keys, but it is a little dumb. And then this is, do you guys remember RDFS member? You guys familiar with that? So in RDF, you have like RDF :1, _2, _3, right? And they're all, according to the RDF semantics, they're all subproperties of RDFS member. So RDFS member is like, I don't care what the index is, but it's in here. Right? This is my version of RDX member has. So this is the other case in which I use a tagged URI. Time was getting short, I'm gonna be honest with you. I didn't have time to go give you another access point to look up one property. I slapped it on the end of a tagged URI, and that's what I use for RDFS. And you're probably wondering why I recreated all of that. We'll get to it. And then there's the other one, metadata. So if you remember when you add metadata equals 1, all that metadata about connections and fields was in an array. That was the object or the key that said metadata. So if I see metadata, that's my sign to say, don't interpret this as instance data anymore. Well, you do, but make sure that it conforms to the schemas that you put out through /schema or whatever. So it's just a little more special. All right. Well, I just like talk endlessly about JSON and text and stuff.
Is there no typing in the JSON at all? Or is there you say properties to type in their instances and stuff like that?
Sure they do. Type.
Oh, okay.
Like,
So yeah, they had the typing for
like this is the thing that I need in order to do what I do.
Okay.
But if they didn't tell me what type it was, I couldn't do anything for you. And fortunately, they were already doing that, so I didn't have to. Like I said, I can't twist people's arms and ask them to change their code and whatever. So fortunately, like all of this was already here, so I had what I needed. Because they had a lot more important things going on, to be honest. So.
A lot more
You guys
different things going on.
Well, you like Timeline, right? Timeline's pretty great. You guys all use Timeline? You don't like Timeline? I'm always in the minority. I love Timeline. Examples of data. So this is some more small text. So I want to encourage you to kind of play around in curl. I use curl to get the turtle, but there's also a plugin for Firefox called Modify Headers. And that way you can change the preference of the MIME types it asks for to give text turtle preference, and then you can look at the turtle in your browser. So here are just some examples. Again, this is the JSON for me. I've got my 7 properties that everybody says is not enough, it's not interconnected. It's people's permission, and you can look at their other stuff. And then here's the turtle version. Right? So the other thing we tried to do is we tried to make the turtle version look nice and readable, similar to the JSON. So this is what came out, basically. This is a relative URI, which if you know your turtle, it's going to resolve against whatever you put in to get this document. It's just going to resolve against graph.facebook.com. I've got my user ID property, which didn't come out as an integer. It's still a string, even though it looks like an integer. Got my name, my first name, last name, username, gender, locale. But I don't know what that is. It's some kind of blip on my. Well, that's why I did a bad job of cutting and pasting. There's something below. There's an underscore there. But all these URIs are dereferenceable. You can see the namespace URI for user is here, /schema/user hash, whatever. Okay, so this is the boring stuff that everybody knows about. Let's look at some of the more interesting stuff. In the Graph API, you can do a search, a keyword search, for public things based on the words of the current. So you can just do graph.facebook.com/search, $Q equals, put your keyword search in there, and it'll return you a whole bunch of stuff based on that keyword search that's public. It's not going to violate anybody's permissions. So you got a whole bunch of stuff back. I kind of scrolled down to one thing that was returned. Here's your thing that has an ID with an underscore in it, right? So this really happens. I didn't make it up. It's from Bogdan. I don't know how to say his last name. There's just a bunch of interesting information in there. You got your picture. It looks like a URI, so it got turned into a URI. This looks like a date time, so it got turned into a date time. Here's something funny. Application null. Application null. What should I turn the null into? I don't know either. So you got an empty string. That was not by choice.
What does that mean, or what's the name behind this application property?
I asked. Like I said, the people who generate their JSON, they get to put whatever they want in there. But you will notice there are a few differences between these properties. Some of them have the link namespace, right? Link colon name. So a link has a property called name, but application doesn't. It's one of those things that got added in somewhere. I have no idea what it means, application null.
Do you determine that through your lookup of what you already know about and what's just something you've never seen before, and you just give that a generic?
Yeah, I mean, I take this ID, I say, let's look up what. This will have a bunch of IDs in it. I take all those IDs and also give me types for all those IDs. Right? So I get that. In this case, I got a type back. Right? I got link. That's type. Right here. I say, okay, let's look up what properties are associated with link. Oh, there's ID, from, message, picture, link, name, description, icon, creative time. But there's caption and application left. Well, I did what I could. I found as much semantics as I could give you. So here's the dumb property. Dereference it, and it's going to tell you this is a dumb property, just like a JSON key, but it's a URI. Yay! So, sorry, it's kind of the best effort there. So that's kind of what I want to show you. Also, this API namespace. Let me see if I can get back up and show that to you. Here it is. The API namespace, that's the tag. So I did end up using the tag URI. Here's another thing that was in that same result, right? I found something here. It's a type of status. It is also an ID with an underscore in it. This application actually has some information here, right? So I went ahead and said, okay, application is whatever this thing is turned into RDF. Well, this thing has an ID, so I gave it the ID for that instance. So these are just some examples of what your RDF looks like in Turtle. Please feel free to stop me. Oh, I'm kind of blowing through it.
So you're transforming the vocab as well, right?
I'm sorry?
You're transforming the vocabulary as well? Use reference the predicate?
Yeah, you reference it, it'll give you something. If it's HTTP, it'll give you something. And you'll be able to find RDF. Well, but you gotta ask for Turtle. You're not gonna get application / RDF. But
Why is for this application ID? Why is that relative to this? Is that relative to graph.facebook.com, or that the actual whole URI itself? Why is that?
are you talking about the relative URI?
Yeah, the relative URI.
So like in Turtle, my Turtle does not include a base declaration.
Okay.
So all your relative URIs should be resolved against whatever you stick up here.
Yeah.
So since I started with a slash, that means you're just going to replace the whole path here.
Okay.
It's not going to be at the end of, cubicles go. It's going to be /117458072. And that was so, if they start hosting this somewhere else, or they pick a different host name, it's all relative.
Yeah.
Alright, so we talked a lot about how we form the URIs, how we translate the JSON into RDF. And let's talk a little bit about the schema. We didn't talk about the structure of the schema. We just said, well, here's how we make property URIs, here's how we make class URIs. But what's the relationship between all of them? Very little. So here's an example. If you guys want to curl this, it's really hard to make good slides of this stuff because there's so much text and examples. If you want to curl this, you can do curl -H accept :text/turtle, and then your URI is http://graph.facebook.com /schema/user. So right, this is your schema information about the user class. So I didn't just have a bunch of comments here or whatever. So these things have like domains, ranges, some of them are subproperties, some of them are subclasses. Here this is user type. I made it an RDFS class. Anybody want to guess why I made an RDFS class and not an OWL class? Jim's grinning at me, wondering about my answer, I guess. My rule of thumb for anything that's not severely logical or severely scientific don't need the OWL part, don't use the OWL part. It's an RDFS version, so I use the RDFS version. It's not to say I didn't use any OWL, right? Oh, here's an OWL data type property, right? So RDFS does not have a concept of data type property, although I can give like a range of RDF literal parts that nobody uses. I think data type property is much clearer to people. So I just went with what was simplest and most readily understood by most people. So all of your classes in here are RDFS classes. You've got this label user. All your properties, I went ahead and looked up the meta information, gave it to you. ID is a special case. Like I said, every class has its own semantics with ID. The real reason I had to do that is because all of their documentation is specific, right? So what's the RDFS comment? The user's Facebook ID. Well, if you ask me for page ID, I can't describe it as the user's Facebook ID. Right? So I have to put this in as something specific to user. But don't worry, I'm in a subclass of the dumb property ID. Right? So everybody's ID is, I'm sorry, subproperty. Every class's ID property is a subproperty of the generic, dumber version of the ID property. And you know, its range is string, like I said. Keep it a string, never interpret it as an integer. The domain is user, obviously. And the only, I think, this is the only one that I dubbed an inverse functional property. Alright, so things with the same ID are the same thing. I mean, that's kind of another useful thing of using those tag URIs for the IDs with underscores in it, right? I put a blank node there, and people fetch different documents. When I was identifying an ID with the blank node, they'd never know they're the same because of the semantics of blank nodes. So in order for people to make sense of this inverse functional property, I gotta put in, you know, something that has the ID, but it can't be the blank node. It's got an underscore, so it's HTTP, so, you know, just use the tag URI. And that way you can have that global identifier, you can get your inference out of it, you can do your inverse functional properties. Third party ID, username. You see what kind of properties these are, by the way? No, because it's too small. They're just RDF colon property, same idea. I didn't need, and the tricky thing about fields, like I said, is fields are kind of data type properties, sometimes it's a link. And all I do is I say, well, if it looks like a URI, I'm going to make it a URI. So I can't really declare any fields a data type property or an object property. I can't guarantee you what will be at the object. So all my fields are just RDF properties, except for ID. ID is always special. Oh, this is all the stuff I already said. All right, what I've curled here is one of the dumb properties. So this is schema / tilde / name. As you see, I get the 303 see other. Tells me to look at schema !, tag equals name. So I go ahead and follow that, get my 200 okay, and this is the information I get. And so I already showed you the JSON version of this. The Turtle version of this is no more interesting. Tag, having no semantics, the unconventional semantics of the JSON key name as used in the Facebook graph API. Okay, forgot I had these animations. Like I said, ID properties are always special. If you look up the dumb version of ID, I don't just give you that lame description, although that's in there too. I also say its range is string, and it's not just an RDF property, it's an inverse functional property. All right, a lot of more small text. Now I'm going to talk about my solution to container membership properties. Marginally better than RDF container membership properties. You'd be surprised how many times I went back and forth on this. I had like 3 different solutions, and I just landed on this one. I think they got tired of me submitting code diffs for this one feature that really didn't matter that much. So I treat tags that are numeric special. You know, you have your keys and they're dumb, but if it's a number and they're all numbers, then I should think, no. These do have meaning. These are indices in an array. Right? So if your tag, your property is tilde / a number, or tilde / underscore in a number, that way you can form a valid Q name, right? With an underscore. Then you'll get back something a little more special than the description saying it's So here, you put tag equals 0, and you say, okay, the property underscore 0 is an RDF property, but it's also a subproperty of API has. You remember that tag property has, it's my version of RDFS member. So far, it's exactly the same as RDF. The real difference is right here. API index 0. Why is this an improvement? Or why do I think? Why do you think I think this is an improvement on RDF container membership properties? Or RDFS container membership properties? Because the big complaint about RDF container membership properties is that you specify the index of the thing, RDF underscore in, but you have no structural way to get at that other than parsing the URI, right? So if you want to make a Sparkle query that says, give me the 5th thing in this list, you end up doing like a regex pattern in the property, and you search with a variable in the property section, and so you know, very low selectivity, and you gotta apply regex over all that, and your server falls over and dies if you have too much data. Now this way, since we've actually made the index explicit, you can say, give me the thing whose property, so you still have to have that variable in the property, but then you can say the property has index 0, so that's another triple pattern, and that way you bring down that bring up that selectivity. You know, here's another one. This is for 1, same thing. Here's one. I put tag equals 1. I put tag equals underscore 1. They're both going to tell you about underscore 1, so I took that into account. And here's one that says -1. You're not going to get anything special. And it didn't count negative numbers. I guess the other thing I didn't think about in the moment, we actually have a 0. So RDF container membership property start at 1. If you want to 0 index your stuff, you can do it. So I've shown you a lot of examples, kind of blown through this. I hope it was well understood. That's what I have for the presentation portion. I'm very happy to open up to discussion and answer any questions or take any ridicule, whatever people have to say. Yeah.
Why are they willing to have a semantic web guide to throw on Facebook? Why are they willing to deal with you? If you're that thin layer.
That is a really good question. I guess sometimes if you make it without people asking, you already have it, and people are willing to look at it. Kind of it's easier to ask forgiveness than permission kind of thing. If I just did it, hey, I did something. Look at this. It came at the cost of doing my assigned project, but sometimes I just enjoy doing things I actually have interest in.
So wasn't their objective to explore how?
No, but they do got a couple guys who think maybe there's something to this. Kind of, the overall attitude is kind of indifference, to be honest.
Right.
But it's not. They're not against it. But I don't think that they're convinced of its value yet. And so I'm hoping that something like this, people will use it. Like if I'm going to be brutally honest, to my knowledge, not a lot of people do, because they go and they see those 7 properties and they go, oh, it's only 7 properties, I can't even connect to my friends. And I try to explain about permissions and they need a security token, and people are like, it's too much. You know, I can't change that. Like they should respect your permission. So I don't think they should put it all global out there because people don't want to get a security token or an access token. So to answer your question, I just did it, and they said, looks ugly, try again. I did it again. He said, okay, make a few small changes. Okay, deploy it. Nobody's gonna, you know, like it's very hidden, right? Unless you specifically go in and you can content negotiate for text turtle, you will never see it. And it's on top of all their JSON stuff, so nobody has to do anything to change anything. The only other code I had to change was to enable a 303. Put in like that, made my little link data redirect exception, put in that catch block, like 5 lines of code in somebody else's thing. They said, all right, I guess I can live with it because we got better things to do anyway. So here it is. You know, it's exciting to me. I hope it takes off. But they did say if people don't use it in a year, which would be September of this year, then they may just axe it because of maintenance issues. hopefully, I haven't seen anything change. Everything looks exactly like I left it. So hopefully, if they find out, well, I don't know if people are using it, but we haven't had to mess with it. Not biting anyone. Hopefully, they'll just leave it in.
How do you foresee people using it or going forward with data? So are you, is this something you see as people adding to their profiles or using Shocker, that kind of thing, and connecting to Facebook in a more linked data fashion than we normally could, or?
That is one thing I think you can kind of integrate with Facebook. Right? So other than the Open Graph protocol, which is a way of basically hooking things on the web into Facebook, Facebook is still essentially a big silo, a fantastic silo, but still a silo nonetheless. And so I think one thing is, you can link into the rest of the web with it using RDF and Git and all that. The other thing is the whole idea behind Graph API, like I said, is it targets developers. Developers want to build applications, and when you go on and play Farmville, for example, and Farmville needs your permission to access certain things, you say, heck yeah, I want to make a farm, so take all my data, and you say, approve it, and then they get that through the Graph API, but it's not like you've approved it for everyone. They have to come in with their security token, basically identify themselves, so, you've only allowed them to see it. Similarly, you could do the same thing with a linked data application. The only difference is, instead of asking for JSON, you're going to ask for turtle, and you're going to do whatever you want.
So Jess, seems to me, given sort of the talents both in the room and extending the room a little bit to our labs, would be the obvious place for someone to try to fool around with some of this stuff, so that when they say no one's used it, someone can say, are you kidding? Look, there's this whole metadata of XYZ, talking to Facebook using this.
I can't say no one's used it.
Well,
I'm not on the inside loop on this anymore. Right?
No, but what I meant was, but it seems to me we could be an interesting user of it, at least in a visible academic way, if we could tie it to any of our ongoing projects or things like that. And a lot of things we know about, either through DBpedia, through government work, etc., have Facebook pages now. So it's not just people, right? I suspect it's hard to come up with any kind of interesting thing we could do that would, not get us in trouble if we want to actually start getting person data and things like that. But a lot of the things that are open are...
Yeah, there's a lot of things that are open. That's the thing. People are always thinking about the social network aspect, and that's where you have to start respecting permissions and stuff. They have a lot of things about places. Where is this place located? That's all available. I can tell you where.
And so it just seems to me like this would be a good project for someone who'd A, like to get much more familiar with Facebook, B, play with sort of Facebook's meets RDF. I'm obviously looking at some of the undergraduates as I talk about this, but anyone would like to do it. So, we've got all these place pages for our states and for things in states. We've got people, we've got who visited White Houses, we've got, this would be a good way to go back through some of what we used to do on the White House visitor list, bring that up to date and start saying, hey, so one of our big issues was, you get a name of someone being visited, you want to be able to find information about them, so we're dereferencing to DBpedia, but this is Vivek Kundra, here's how he's known in Facebook would have been a more, perfectly doable thing. Or, walk through, grab somebody's schema.org stuff for which has a Best Buy with the good relations in it and throw it to them. So here's linking Google pages to Facebook pages. No one else is playing in this space. Those things are generally hard because you're really just talking about... So in JSON, you can get all of the same data structure built, but then, of course, you have to have your own infrastructure for doing stuff with it, which the JSON guys have for games and apps and things like that. We have the RDF infrastructure for a lot of this stuff, so we can put it in some place, you can sparkle it and build a mashup or a visualization or something. It just seems to me it would be a great place to play. We have one of the world's experts on what comes out and what the stuff looks like, who's hanging around the lab at least for another year. So
Hanging around is
at least through September. Well, I suspect if
working away.
I suspect if one of these guys wanted to do a project in this stuff, you could find a few minutes to help out here and there.
Yeah.
Especially if it meant that in September when they looked and saw something that had shown up on the White House page or Microsoft said something nice about or something like. I mean, you know, we can get good visibility for this stuff if someone has a good idea. You know, this would be a great way to kind of help make your bones in this space. So think about it, guys. If somebody, and I'm sure I'm sure Jesse could come up with some ideas of what you could do if you want to play with it. Some of the visualization stuff we've done. You know, throw
Here's
that
an
against
example
some of
right
these
here.
things.
So like I just did a Google for Facebook Arkansas. So Arkansas is my home state. Okay, so it turns out Facebook, there's an arkansas.gov page at Facebook. Isn't that beautiful? It's a natural state, a bunch of dead trees in the way, right? Anyway, they have all this public data that you can see that they have a vanity URL, username. We call them vanity URL. Called arkansas.gov, so I just went to the Graph API and put graph.facebook.com/arkansas.gov. Here's all their structured information about arkansas.gov, or the state government of Arkansas. You got location, you got your latitude, longitude here. Those are going to get translated into decimals and translated as a zip code, state, Arkansas. I mean, there's a lot of stuff here. It'll tell you when they're open and closed. Apparently it's Monday through Friday from 8 to...
The whole state.
Yeah, you guys gotta be careful. You go across that border, get in there before 9.
Well, but there you go. Somebody who we happen to have 50 pages, so it's actually 57, I think it is, state pages that are
it'd
states
be
and
cool to get an
territories,
info
all
sub
of
or something
probably
like that.
all of which have things related to them in Facebook, whether it's Arkansas Gov, whether it's Georgia, some organization, you know, and to build a little tool that could sort of wander some of those things, do some interesting things in, you know, the Facebook API, and either put them into our pages or make them live linkable, you know. See the RDF for this thing, and, you know, suddenly people start to get the linking idea. That
Yeah, I think I'd be interested in it. I'll look for the state stuff and add that to the state Insta Hub. And for other things,
We've got all the,
Insta Hub
you know,
is-
we got agencies, we got
Yeah.
a bunch of other
That's
stuff.
really
Plus,
fun.
we got a bunch of stuff in data sets that we've never done, that there's probably a lot of stuff. So I'm sure there's a product data set or something. So, well, there's a product recall data set, and all those products have pages in Facebook, so we could write a little thing that says, hey, you know, want to see what's been recalled from those products you're looking at? I don't know if it would make us popular. Actually, it would make us very popular because one of the big initiatives about to roll out for the White House, I'm going to the announcement on Friday, is what they call smart disclosure, which is sort of giving consumers information from government data sets where they can build apps from. You know, showing if I'd seen this 2 weeks ago, one of you guys would have built that by now. So I could have on Friday said, hey, let me show you something cool. You know, here's the recall page for that thing, you know, here's so it'd be really good for someone to sort of fool around, play with this stuff, see what we could do.
Yeah, something. Yeah.
And, you know, but do a real project. I mean, this is the kind of thing where not, let's do a 2-minute hack, although that would be good too. But, you know, somebody actually think about using this as an infrastructure. So if you want to visualize anything out of Facebook, you have to pull it out of Facebook. If you pull it into JSON, right? I don't have an infrastructure to sparkle JSON to, you know, to Google Viz. But boy, you guys got access to a whole bunch of things to sparkle this, turn this stuff into, you know, stick it in our triple store and sparkle it, and so you could live pull stuff and, you know, visualize it. And it'd be very, very, very cool stuff. But, you know, I'll tell you, especially the undergraduates, that, you know, you want to make friends, win influence, and also have a good job at the end. Say, look at this cool Facebook thing I did. It's really big. And it's not hard. I mean, Jesse's done the hard work for you. So all of you should think about this, but especially any of you who are looking for a project to really do something fun, or a friend who wants to do a project, or want to intern at Facebook someday. So you need to get familiar with this.
There are a few things that I didn't talk about in this presentation. For example, if you go to your browser, let's see, who's familiar with custom open graph? Anybody? The custom open graph is kind of like their open graph protocol, except they're letting people make ontologies. They don't call them ontologies, which allow you to create these open graph terms so that other people can basically use RDFA to mark up their stuff. Zynga will make theirs, and they'll have like farms and crops or whatever. So custom open graph is like that, but you know they have all these URIs, and the URIs don't really go anywhere. So schema solves that problem too. Let me see if I can find it. It's been like September since I was there, so. Custom open graph.
Just by way of page, you should all look at. This is a very full page. Think that.
So I guess I'm having trouble finding it, sorry, but fortunately I have it all memorized. So now there's more than, so what was it Open Graph used to have was people and website and all those OG types, right? So now they have a few more like book and article. There's kind of a fine distinction between, say, something like book, which is this idea of a general topic, general class of things that are interesting to all, and the things that they've kept separate strictly in their OGP stuff, what's not in the custom open graph. I probably shouldn't get into those details, but what I'm trying to show you is, if you go to graph.facebook.com/schema/OG/book, okay, so we provided schema information about the things in the custom open graph as well. I guess this may not be the custom part technically, but, so when people go in their RDFA and they mark something up as OG type book, well, when a crawler follows that link, they're going to end up over here in schema, the thing I've introduced here. They'll find this information. What you'll notice is this schema has something special. It doesn't just have the properties like the other ones. It also has subtypes. So the top level property the top level thing is open graph object /book. Right? An open graph object is your top level thing, but then it has a subtype called book. So this, if you look at the RDF version, this gives you some subclass hierarchy and things like that. So it's hooked into the custom open graph and some of the open graph protocol as well in terms of helping their things actually dereference. The more common things that were there before go to a flat file. They don't come to they do dereference.
So just not long after you left, they talked about how the big new thing in Open Graph was the ability to, quote, create verbs, unquote, which of course I take to mean relations. Was that the custom Open Graph they were talking about? Or is
Yeah,
that
that's part of it. There's going to be your classes, obviously, but there's also the actions, like you read something and they push into Facebook and say, you know, the app pushes something to Facebook and says, someone just ran 3 miles around this thing. It shows up in your newsfeed, and that all gets pushed in through a bunch of custom actions and things that are specific to that app.
Now, what happens to the back end? I mean, so let's say I have in my application space, say, buy. So now we have no, like, and buy. So that gets pushed back, but, they wouldn't know what it means unless, or is that when I define the custom thing, what it's about?
You saying how you find the semantics of it?
Well, how would they use it? So they'll add it to the graph, apparently, but how do they...
How
But
does who use it?
Will they Facebook? So I thought the idea was you add these things, you mark up things with it. They'll consume that. Therefore, the graph will grow with that stuff in it when you or you use it. But then they'll quote use it. But I take it that's just they find things that are new, and if something's being used a lot, they say, how do we exploit it? Or
I mean, the custom open graph stuff is for application developers. So we can use Farmville as an example. They're the ones creating these custom actions and pushing these things in there, and it pops up in your timeline. But I'm afraid to speak too strongly, but I believe that Facebook is basically just supplying, the storage and the way of publishing a story or whatever. But there's some degree of interface with the developer, how they choose what kind of things show up, what kind of actions they have, and that kind of stuff. So there's some interplay there. graph actions, you'll never see those in RDFA. There's no URIs for that. I mean, the actions are distinct from, you know, the Open Graph, OG, name.
Well, when I click a like button, okay, so in theory, the graph now says there was Hendler has a like relation to this page in whatever way that's stored. And I assume, I mean, I know they don't store it in RDF, they store it in whatever the internal format that then they spit out in JSON is, right? But so an event occurs, it causes the graph to grow, and apparently, and I thought the whole idea of the new OGP was that developers, and particularly groups of developers who may be in different companies but wanted some, quote, consortium notion of that, could grow the graph, could define things that would grow the graph. So a bunch of e-commerce guys could say, we all want to know, we want to not know when somebody likes something on a page, we want to know when somebody buys something on a page, so we'll all share this relationship or that. I don't know if that was happening yet when you were there, or whether that's still just being talked about.
I guess I just have to say there is something like that going on. I'm just fuzzy on the details. Don't think I can answer that in a way that would do it justice.
But you'll give it good URIs.
Yeah,
Fix it there.
that's why I tell you, if you can get something out of the Graph API, you can get it in RDF. Your worst case scenario is you're going to have all dumb